Shweta. Now I am going to discuss about motion. Motion is nothing but an object changes its position with respect to time and surroundings. For example, when a car is moving on the road, it changes its position continuously with respect to time and surroundings. Surroundings is nothing but trees, houses, etc. So then a car is said to be in motion. And some more examples we have in our surroundings. A train is moving along a track, aeroplane is flying in the sky, a fan is rotating around the wheel. These all are the examples of motion. Not only the objects on the surface of the earth, even the earth is rotating around the sun. So these all are the examples of motion. That means everything in the universe is in motion. Next I am going to discuss about rest. Rest is nothing but it is exactly opposite to motion. That means an object does not change its position with respect to time and surroundings. Then an object is said to be at rest. For example, I am standing here. I am not changing my position with respect to this room and also time. The time is changing 1 second, 2 seconds, 3 seconds like that. But I am not changing my position with respect to this room. So that means I am at rest position. So some more examples. A book is lying on a table, bench, pen and chair. These are all the examples of rest position. Next. Rest and motion are relative terms. Yes, rest and motion are relative terms. Relative terms, this means an object can appear to be at rest to one person. The same object can appear to be in motion viewed by another person. For example, you and your friend is sitting inside the bus. The bus is in motion. Suddenly you saw one more friend, he is standing on the road. So with respect to the third person who is standing on the road, with respect to that person, what is your position? You are in motion. With respect to second person, you are at rest. So that means what is your exact position? We can't say you are at rest or in motion. That phenomena we call it as a relative. So rest and motion are relative terms. And one more example, earth. So with respect to us, the earth is at rest position. But with respect to sun, the earth is in motion. This is also example of rest and motion. Yes. Next I am going to discuss about some basic definitions of motion. That is distance and displacement. Yes, ma'am. It is nothing but the actual length of the path covered by a moving body in irrespective of the direction. That means in any direction. That we call it as a distance. I will give an example. If you want to buy a vegetable, where you want to go? You will go to market. First you started your journey in your home. This is your home. And after so many turns, finally you reach to the market. Yes. If anybody will ask you, suppose your friend will ask you, how much distance from your home to market means, how you can say? You can say whatever the length you covered from your home to market, that you can say in terms of meter or centimeter. So that we call it as a distance. So distance is nothing but the actual length of the path covered by a moving body in irrespective of the direction. That means in any direction. That we call it as a distance. The actual length of the path covered by a moving body in irrespective of the direction. That we call it as a distance. Yes. So just observe here, distance is a scalar quantity or vector quantity? It is a scalar quantity. First, what is meant by scalar quantity? Scalar quantity is nothing but the quantity which having only magnitude, no particular direction. That we call it as a scalar quantity. So just observe here, this having a magnitude, that means 5 kilometers, 10 kilometers like that. But it is not having particular direction. So that's why it is a scalar quantity. Yeah. Can you say what are the units? First, SI unit is meter and CGS unit is centimeter and dimension formula is L power 1. So this is about distance. Now come to the topic displacement. Displacement is nothing but the shortest distance between initial and final point. So which one is the initial point here? This one. So which one is the final point? This one. Yes, ma'am. This is the initial point. This is the final point. So just draw one line from home to market. That means that is the shortest distance. So is there any other possible direction? No. So this is the shortest distance between initial and final point. That we call it as a displacement. What is meant by displacement? The shortest distance between initial and final point. That we call it as a displacement. Just observe here, displacement having particular direction. Displacement having, this is displacement and this is distance. Yes. Displacement having particular direction, that means it is towards east, and distance having so many directions. At this point this is the direction, at this point this is the direction, at this point this is the direction, and at this point this is the direction. So it is having so many directions, that we call it as a distance. And displacement is nothing but having particular direction, that we call it as a displacement. So can you say displacement is a vector quantity or scalar quantity? Displacement is a vector quantity. First of all, what is meant by vector quantity? The quantity which having both magnitude and direction. That we call it as a vector quantity. Just observe here, displacement is also having both magnitude and particular direction. Magnitude is nothing but 5 meter, 10 meter like that, and also having direction that is towards east. So that's why displacement is also a vector quantity. Displacement is a vector quantity. Units. Actually, SI unit is meter and CGS unit is centimeter and dimension formula is L power 1. So distance and displacement both are having same units and dimension formula. Yes. Next. Next I am going to discuss about speed. So speed is defined as the rate of change of distance, and one more definition, the distance travelled by a body in unit time, that we call it as a speed. So this means by speed, speed equals to the rate of change of distance, nothing but distance by time taken to cover that distance. So this we call it as a speed. For example, when a car is moving with higher speed, it covers a larger distance in a given interval of time or a given distance in shorter time. That means the speed is always measures a how fastest or slowest of a moving body. So the speed, it defines the rate of change of distance, and also it defines as the distance travelled by a body in unit time. For example, when a car is moving with 40 kilometers in 1 hour, what is the speed? 40 kilometers per hour. Speed is also a scalar quantity. And the SI unit of speed is, distance unit is meter and time unit is second, meter per second. CGS unit is, yes, distance is centimeter and time is second, and dimension formula is, distance is L and time is T, so that is L T power minus 1. So the speed is measured by a speedometer, and one more thing, distance is measured by odometer and speed is measured by speedometer. Yes. Next, I am going to discuss about uniform speed, non-uniform speed and average speed. Yes. So uniform speed is nothing but if a body covers equal distances in equal intervals of time, then a body is moving with uniform speed. For example, a car is moving on the road. It covers 10 kilometers in 1 hour, and next 10 kilometers. A car covers equal distances in equal intervals of time. Then a car is said to be moving with uniform speed. If a body covers equal distances in equal intervals of time, then a body is moving with uniform speed. Next one, non-uniform speed. Non-uniform speed is nothing but if a body covers equal distances in unequal intervals of time or unequal distances in equal intervals of time, then a body is moving with non-uniform speed. For example, a car covers first 10 kilometers in 30 minutes and next 10 kilometers in 25 minutes and next 10 kilometers in 20 minutes. So that means a car covers equal distances in unequal intervals of time or unequal distances in equal intervals of time, then a body is moving with non-uniform speed. This is about non-uniform speed and uniform speed. Average speed. Average speed is nothing but the ratio of total distance by total time to cover that distance is called average speed. So that is V average equals to total distance by total time. It is called average speed. For example, a body travels between 2 points, that is A and B. First half of the distance moves with velocity V1 and second half of the distance is moves with velocity V2. So this total distance is S. And first half of the distance is moving with velocity V1 and second half of the distance is moving with velocity V2. Find average velocity. Find V average. Yes. So first, what is the V average formula? Total distance by total time. How much total distance? You know, that is S by total time. So we are taking first half of the distance, that is time T1, and second half of the time distance takes time T2. So that is total time is T1 plus T2. You know very well what is the speed formula? Speed equals to distance by time. So what is the distance? Half of the distance. That means S by 2 and remaining half is S by 2. So what is the distance one? Actually the formula is distance by time. Here if you take V1 equals to what is the distance? S by 2. What is the time period? T1. Like that V2 is equals to S by 2 T2. So take that values and substitute here. But we should convert this one in terms of T1. So T1 is equals to S by 2 V1. And T2 is equals to S by 2 V2. Just take the values and substitute here. S by, what is T1? S by 2 V1 plus S by 2 V2. Just take common S by 2 here. S by 2. That is 1 by V1 plus 1 by V2. Cancel this S's. V average. Take LCM here. LCM is V1 and V2. So V average equals to 1 by 2 V1 V2 V1 plus V2. If you take that 2 V1 V2 upside, V average equals to 2 V1 V2 by V1 plus V2. This is the V average of this question. Next I am going to discuss about velocity. Velocity is nothing but the rate of change of displacement. Like speed is a rate of change of distance, and here the velocity is the rate of change of displacement. So velocity equals to displacement by time taken to cover the displacement. So Here displacement is a vector quantity and velocity is also a vector quantity. And the SI unit is, displacement unit is meter and time unit is second, and the CGS unit is centimeter per second, and dimension formula is L by T, so that is L T power minus 1. So speed, the relation between velocity and speed is, the magnitude of velocity is nothing but speed. That means velocity having particular direction and speed not having particular direction. That is the difference between velocity and speed. Yes. Next I am going to discuss about average velocity, uniform velocity and non-uniform velocity. First, uniform velocity. Same like uniform speed, here also. A body covers equal displacements in equal intervals of time, then a body is moving with uniform velocity. If a body covers equal displacements in equal intervals of time, then a body is moving with uniform velocity. Now, non-uniform velocity. Non-uniform velocity is nothing but, if a body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time, then a body is moving with non-uniform velocity. You know this example. A body is moving with first 10 kilometers in 20 minutes and next 15 kilometers in 20 minutes and next 30 kilometers in 20 minutes. Just observe here, the time limit is same, but whatever the displacement is different. That means it is moving with non-uniform velocity. When a body covers equal displacements in unequal intervals of time or equal intervals of time in unequal displacement, that then a body is moving with non-uniform velocity. Next. Now I am going to discuss about some important points of distance and displacement. First point is, when a body is moving in a straight line, the magnitude of distance is equals to displacement. For example, a boy is walking on the road. He covers 100 meters towards east. So can you say how much distance and displacement here? Yes. What is meant by distance? The actual length of the path covered by a moving body. So here, whatever the length he covers, that we call it as a distance. How much here? 100. So distance equals to 100 meters. And what about displacement? What is meant by displacement first of all? The shortest distance between initial and final point. How much it is? 100 meters. So displacement is also 100 meters. So distance is equals to displacement. When a body is moving in a straight line, the magnitude of distance is equals to displacement. And next, second point. If initial and final points both are same, the displacement equals to 0. I will give an example. One boy enters into a circular park. He covers exactly one circle, full circle. And he reached to the same point, initial point. Yes. So can you say what is the displacement here? Displacement is nothing but the shortest distance between initial and final point. Here initial and final points both are same. So displacement equals to 0. If initial and final points both are same, displacement equals to 0. Yes. So next one, distance by displacement is always greater than or equals to 1. That means if you take the displacement in this side, distance is always greater than displacement. So distance is always greater than displacement or equal to displacement, never be less than displacement. Distance is always greater than or equals to displacement. And next point, yes, next point, fourth point, yes. Distance never be 0, never be negative. It is always positive. But displacement can be 0, can be negative and also positive. I will give an example. This is the coordinate system. This is positive x-axis, positive y-axis, and then negative x-axis, negative y-axis. For example, this is the origin. A boy started journey here and he is moving towards positive x-axis and he stops at this point. That he covers some 8 meters. Yes. Can you say what is the distance and displacement now? Distance is equals to the actual length of the path covered by a moving body. How much length he covered? 8 meters. And how much displacement? Displacement is also a 8 meter because the shortest distance between initial and final point, how much it is? 8 meter. Now, again that boy turned back and he reached to the same initial point. Yes. So, can you say what is the distance and displacement now? Distance is equals to whatever the length he covered, that we call it as a distance. So, first 8 meter and then 8 meter, total 16 meter. And now displacement. Displacement how much? Displacement is nothing but 0. Why it is 0? Because initial and final points both are same. If initial and final points both are same, displacement equals to 0. Now, again this boy, he moves towards negative x-axis and he stops at this point. He covers 8 meters in negative direction. So, what is the distance and displacement? Yes. What is the distance? Whatever the length he covered from initial point to final point, that length we call it as a distance. So, first 8 meters, again 8 meter and then 8 meter. 24 meter. How much displacement? The shortest distance between initial and final point. This is the initial point. This is the final point. So, how much it is? 8 meter. Is it right? No, because we should indicate direction. This is the displacement. Displacement having both magnitude and direction. So, we should indicate direction. Which direction it is? Negative x-axis. So, negative minus 8 meter. So, just observe here. Distance is always positive quantity. But displacement positive, 0 and also negative. If you observe one more thing, distance is always greater than or equals to displacement. Here it is equal, here it is greater, here it is here it is greater. So that means distance is always greater than or equals to displacement.